In this video, I will be discussing my results from the Charged Tapes lab. Before describing the lab itself, it's important to have a thorough understanding of the overarching physics principles that will govern our experience in the lab. The law of conservation of charge states that the sum of charges in the universe remains constant. Although charges cannot be created nor destroyed, they can be transferred among objects through physical contact or processes at a distance. Coulomb's law states that the electric force an object experiences from a nearby object is proportional to the product of the charges of the two objects divided by the square of the distance separating them. There are two possibilities for how the object experiences an electric force from a nearby object. It can either be drawn toward it or repelled. In this lab, we will witness one of these two scenarios and draw a conclusion on whether the objects had like or opposing charges based on the interaction that occurs. The motivation for this lab was to compute the charge of a piece of tape. We began the lab with two strips of neutral tape with handles on them called U-tapes. An additional strip of tape acted as a base tape where the transfer of charges to or from the U-tape occurred through contact. Note that at this point in the lab, we were able to confidently state that U-tape has a positive charge. This is because when U-tape was put into contact with a positively charged pen, the two objects repelled each other. After quickly breaking contact between the U-tape, tape A, and the base tape, it was placed between two stacks of books. This process was repeated with the second U-tape, tape B, which was placed below the first U-tape. The tapes were brought closer together until tape A was visibly suspended a certain distance. The distance was computed as the difference between the final and initial positions of tape A in meters. Note that the length of the U-tape was also measured and that this value was considered to be consistent for both tapes. I used a free body diagram to model the forces acting on tape A. Neglecting air resistance and treating gravity as a constant force of negative 9.81 meters per second squared, I found that the two major forces acting on the tape were the electric force from the bottom tape acting in the positive y direction and the gravitational force acting in the negative y direction. Using the estimation that tape is 1 gram per meter, I found that the U-tape has a mass of 2.012 e to the negative 4 kilograms and that the gravitational force was negative 1.974 e to the negative 3 newtons. Since tape A was momentarily suspended, the sum of forces in the y direction was 0 at 1 instant. The gravitational force is set equal to the electric force to solve for the charges on the tapes. Note that it is assumed that the magnitude of these two charges is the same for simplicity. When the observed separation distance is plugged in, 0.005 meters, the magnitude of Q is found to be 2.34 e to the negative 9 coulombs. Since we observed that the two tapes repelled each other, it is assumed that the sign of their charges is the same, both positive. By dividing the charge on one tape by the charge of a single electron, it was determined that each U-tape had an electron deficiency of 1.46 e to the 10 electrons. I modeled this experiment on GlowScript using spheres to represent the tapes A and B as point charges. This image produced by my code shows the magnitude and direction of the forces acting on tape A, which were the electric force from tape B and the gravitational force. Although only one set of arrows is drawn for simplicity, due to the law of reciprocity, the same force is being exerted on tape B by tape A. I will conclude with my answers to two conceptual questions. If the charges on protons and electrons were reversed, the same interaction would be observed among the two U-tapes, as they would both have identical negative charges and would therefore repel. However, while being stripped away from the base tapes, there would be a net gain of negative charge since they would lose positively charged electrons. It was important to handle the charged tapes as little as possible so that charge was not lost or gained from objects in the surroundings, specifically the table or your hands. This would lead to propagation of error when tapes A and B finally were in contact with each other. Thank you!